Hello, and welcome to the Future Ready podcast. I'm your host, Spencer Kane. Today, I'm joined by Samir Desai, Senior Director for AI and Data Strategy at Siemens Digital Industries. Welcome, Samir.
Well, thank you, Spencer. Thanks for having me here.
Yeah, it's a pleasure. So, before we start things off, can you tell us a little bit more about yourself and your background?
Sure, yes. So first of all, really excited with the series that we're going to do here, Spencer, with you. Talking about me, my current role, I lead the cross-business AI and data program across our Siemens Digital Industry businesses, software businesses. And it involves several key aspects, which start with what is the AI strategy, what are the AI technology stack, coordination and governance across the cross-cutting business projects, customer engagements, field enablement. It's a pretty broad role. The more fun part, a fun fact, I just finished 30 years in the company, beginning of the month of April. And I've had a long and diverse journey. I started as a software developer for our CAD product. And over the years, I've done several technical, business, and global leadership roles across multiple product lines within the accelerator portfolio, touching our CAD, PLM, IoT, low-code integrations, and several other product areas. So it puts me in a very interesting situation to do my current role right now.
Yeah, it sounds like you're uniquely positioned to have an understanding of all of the software offerings within Siemens and what it means to bring AI to them. But kind of in a broader sense, of course, everyone is talking AI right now. It's not just us, it's not just Siemens, it's not just, Rockwell or anything, but you also have the big guys like NVIDIA and AWS, Microsoft. How is Siemens set apart from all these large AI focused companies as well?
Oh, very, very important question. Because, when we look at AI today, we see the fact that, it's touching everybody all the way down from kids in elementary school to their grandparents and everybody in between. And it's very important and critical to understand for our listeners here in terms of what is the difference in what we see with these different types of AI offerings. So let me start by saying this is the differences in terms of AI infrastructural services versus industrial domain AI and AI that is applicable to engineering and manufacturing. So what do I mean by this? So when you look at the companies, like the ones that you mentioned, Spencer, AWS, Microsoft, NVIDIA, they focus a lot on what we call as infrastructural services. Some may call them as foundational or platform services, but the key is whatever AI capabilities that these players and companies are providing are core for the broad set of industries to build their offerings, and the services that they provide are agnostic of a particular industry. So let's take, for example, NVIDIA. So everybody knows the name NVIDIA in the AI business world now. They provide powerful GPUs and related accelerator services for graphics, right? AWS and Microsoft, they're providing services such as large language models or LLMs, RAG or retrieval augmented generation, guardrails on how AI would perform, foundational pieces about how agents can be built, so on and so forth. Now, these services can be used by any organization, any company, as a framework for building their specific specialized AI offerings. And the other part that these great organizations do is they provide these services at scale, which is why they are also sometimes called as hyperscalers, right? So in a nutshell, companies like AWS, Microsoft, NVIDIA, and their peers are providing infrastructural AI services at scale that can be used by several organizations, several companies, several businesses across any industry to build their specific AI capabilities. Now, what is it that Siemens does and that is different? So at Siemens, we deliver industrial software. That's our big part of our DNA and our bread and butter. We provide these industrial software across multiple domains, such as design engineering, manufacturing processes, simulation, operations, and so on and so forth. What our customers do is they use these softwares to build their products, such as cars, planes, satellites, phones, machines, factories, consumer goods. We have a very broad set of industries that we support where our customers come from. And our software is very powerful, that allows the users to do some very complex engineering and manufacturing and operations work. Now, this is where we start bringing in AI for our customers and their users. What we at Siemens are doing is that we are infusing AI in this industrial softwares systems that we offer across all the domains that I mentioned about engineering, manufacturing, operations, simulations. And what we are doing here is by infusing it, we make it highly efficient for our customers and their users. Not only for them, but even our own software. We make it highly efficient by infusing AI. And with this, our users are able to perform their tasks at breakneck speed than what they were before us infusing AI, and they're able to get this competitive advantage over there. Now, the interesting part is the services or capabilities that Siemens provides versus what AWS, Microsoft, and NVIDIA and the hyperscalers provide. Although they would seem and sound like different, they are actually connected. They're in a connection in a way that Siemens partners with these hyperscalers. We, for example, use NVIDIA GPUs and acceleration services in our products to create what we call as digital reality viewers and high-speed visualization. We partner with AWS and Microsoft using their infrastructural services, on top of which we infuse our industrial AI. So, we got the foundational services coming from hyperscalers, the industrial AI coming from Siemens, and we're connecting these offerings together for the benefit of what our customers will get out of it. So it's a long explanation, but an important one to understand how Siemens differentiates from the hyperscalers and what is available in the market at a ground level.
No, definitely. That was a great explanation. Yeah. It sounds more like we're dealing with a complete ecosystem here rather than everyone just being in competition with each other.
Yes. In fact, you bring up a very good example there or a view, Spencer, is ecosystem. Why is the ecosystem also important? Is when we look at a large number of our customers, they already have been on their journey of SaaS adoption and taking and adopting cloud. They have been working with AWS, Microsoft, and other cloud providers and hyperscalers already. We, as Siemens, were already partners with them, and now we are taking this up to the next notch by adopting even some of the core AI infrastructure services. So, us as going together to our customers is a great benefit for everyone. NVIDIA, another example. We work together with NVIDIA, ourselves, and PepsiCo, a key customer for us, to bring a key offering on what we call as a digital twin composer and digital reality viewer with this partnership. So ecosystem and partnership is going to continue to be the key to grab the fast moving services that are coming in the AI world and how we take advantage of that and bring value to our customers.
Definitely, a great way to put it. But now that we've got this great overview of the whole ecosystem, as we've been saying, I'd love to hear more about your specific expertise. You've talked about how you've worked across all of these different tools, software tools that Siemens has had to offer over the years, leading up to your current role as heading up, AI and data strategy within Siemens Digital Industries and our software. So, what does that look like to you? What is the Siemens software industry with industrial AI in mind? Like, what is this program that we're looking at now?
Okay, all right. So with our business units and the way that we build and deliver our products, let me go step back a little bit in how the variety of products that we have. One is an area where customers are using our 3D design tools. There are simulations, there's manufacturability, and so on and so forth. Let me take a particular example to explain this and what it means to the program. So take a car, for example. We have the largest number of automobile manufacturers as our customers. Siemens, period. No other competition has that as car companies as customers as we do. Why do I pick a car? Because everybody either owns one or rides one as a taxi or an Uber or with their friends. What goes in bringing that car on the road? Somebody has to design it, means they have to figure out what the 3D design is going to look like. They have to design how the electricals, the electronics are going to be in that car. Once that is designed, they have to actually simulate how that car is going to perform. The different components of that car are going to perform. That is a different set of users, but it has to work on the same data of the car design. The next step comes in is, well, you designed it, you simulated, now you need to think about how you're going to manufacture it. There's a whole different set of software products that we provide and a whole different set of user personas that we deal with at our customer base who are designing for manufacturability, DFM, the process of how they are going to manufacture it. That also is digitalized using a set of our software products. A lot of these customers use our products to even design the factories in which these cars are made, right? So now you have to design the factory along with the robotics in it that is going to go manufacture this car. Once the car is built, now it's on the road. People like you and me, Spencer, are driving the car. We're sitting in Ubers and going around, and cars have problems. They fail. They have to be serviced. What do you do with respect to servicing this car? What are the instructions to service it? That's a whole different set of people who do this, like service technicians at the dealership, and they have to work at a different level. So when you think about the whole spectrum of what I just described, design, simulate, manufacture, service, support, different personas, different aspects, but it's the same car. Now, how do you connect this to the program? When you look at the different products, these are geared towards specific personas and specific users. When we start bringing AI into it, we're looking at saying, well, this customer is building an electric vehicle. There is an electric battery. We all know that with batteries, there is a constant challenge about how do you increase the range of the battery continuously going in. Now, increasing the range is not a simple thing as go make a bigger battery. It means go make increase the size, simulate the performance, figure out how you're going to manufacture it, figure out how you're going to put it in the car, make sure it is not going to bump against anything else. All these are different actions that people have to take. And what we're doing with this program is, hey, if you had to do even a simple thing like that, what are the places in these different products for these different users? How do you bring AI to them so that when they say, I need to make a bigger battery, we infuse AI into the engineering tool to say, here is a recommendation of how you could do it. Here is the 3D recommendation. Here is a recommendation on simulation. But wait, not only a recommendation, I will even help you through my AI to simulate it. I will use AI to manufacture it. So we start at the program level across the whole portfolio to say what and which places are we going to start infusing AI to make our customers' life and our end users' life even more easier than what we have already made over the last few decades. And that starts getting into the elements of what is the technology stack that we're going to use? How are we going to pull these things together? How are we going to go start working and making sure that the customer scenarios are supported? So we start tying everything together at the program level, all the way from the approach to execution to delivery to customer engagement and enablement to them in there. So that's, this is why the program is cross-cutting, not at a particular product level.
Yeah, I mean, it sounds like you're covering up just a huge breadth here, and that can't be easy. But it definitely sounds like there's a lot of opportunity for improvement and for bringing AI into the fold to help, connect tools, connect data, and make people's lives easier, and all using this huge product stack with all this technology we were just talking about. But unfortunately, that is all the time we have for this episode. Once again, I've been your host, Spencer Kane, joined by Samir Desai on the Future Ready podcast. Tune in again next time as we continue talking with Samir about the real impact of AI in the design and manufacturing world.